Hello students, welcome to my class. In my today's session, we will go through the sensitivity analysis. As I said, the various risk analysis techniques that we normally use in capital budgeting, and one of the techniques that we have is a sensitivity analysis. What exactly is sensitivity analysis? Basically, sensitivity analysis is a statistical tool that helps us determine how consequential deviations arises from the expected value. When dealing with the expected resources and demands, uncertainty is a major factor. So basically, it is an analysis whereby we try to find out how sensitive an outcome is to any change in the variable which are its inputs. So this is an analysis of how many each of the input variable in a capital budgeting decision, maybe a discount rate, cash flow growth rate, might affect the present value, the IRR, while keeping other variables constant. The project's NPV and IRR can be computed here under the following three assumptions. That is, optimistic. Okay, so you'll find all that here, and that is where it is given. Anyways, we have it here. So, the project's NPV and IRR will be computed under the following three major assumptions. One is when it is optimistic, which means we are looking at the project during its best outcome. Most likely is the expected or say the normal situation, and pessimistic is the worst outcome situation. The advantage of this method is that it identifies the critical variables for which special actions will have to be taken. It increases the understanding of the relationship between the input and the output variables. It therefore guides the decision maker to concentrate on those relevant variables for the project. However, the drawback is that it fails to focus on the interrelationship between the variables. Yeah, so however, one thing that we have to understand over here is the terms such as optimistic, pessimistic, and most likely could mean different for different people. It is similar to that of scenario analysis. However, it is a little narrow in scope, while the scenario analysis is broader in scope. But let's understand one important thing, that such analysis helps the companies and the investors to measure the expected value of an investment, right? So keeping all this in mind, let's quickly go to the solution. I've taken up this. Mr. Rusky is considering two mutually exclusive projects A and B. You're expected to advise him about the acceptability from the following information. The two investments that are given to you, the cost of the investment A is 50,000, cost of investment B is 50,000. The forecasted cash inflows per annum for 5 years are given to you, 25, 20 and 15, 30, 20 and 24,000. The cost of capital is assumed to be 15%. Now they've asked you, of these two investments, which is the best? And you're supposed to advise Mr. Rusky, right? So let's solve. Take the situations first. Maybe what we can do is we can take the situations. Situations over here are optimistic, most likely, and the pessimistic. So that's fine. CIF. Situation, CIF, PV at the rate of 15%, that's the cost of capital that's given to you, 15% on an annuity basis, okay, that's very, very important. PV, CIF and NPV, okay. So these are the things that we have to essentially have over here, and let's take the heading as calculation of NPV on the basis of sensitivity analysis, right? Or technique. We need to be little good at Excel, otherwise the data that we are presenting might not be appealing at all. So simultaneously we need to present it in such a manner that it's good to see even, right? So we have optimistic situation, we have the most likely situation, the pessimistic situation. CIF is given to you. Now this is given, this has to be taken for both X and Y. So sorry, A and B. So therefore let me take this as for project A and B. And PV at the rate of 15%. Now here, this is where you have to understand the meaning of annuity. Generally, you talk about the present value of an annuity. It is the current value of the future payments from an annuity, given a specified rate of return or maybe a discount rate. The higher the discount rate, lower will be the present value of the annuity. So we can get these values from the annuity table. So what is annuity table? Annuity table is a tool that will help you to know the present value of an annuity. So you will have to find out the discount rate and the number of period for payment. Consult the annuity table and you'll get the value. So basically it is 1 divided by 1.5. And how do you get the value is total that for 5 years you get the value. Okay, so it's given in the table as I'll take 3.352, and this is going to remain the same for all the situation, because situations for the 5 years are the same. This is not going to, the situations are going to be different, while the PV at the rate of 15% annuity is going to remain the same. So PV CIF is going to be therefore 25,000 into 3.352. So let's take that quickly into, right? So this is 83,800. So we are going to calculate it. And we got it on 67,040 and 50,200. And what is the NPV? How do you take the NPV? Is PVCIF minus the PVCOF. And what is a PVCOF? That's the investment. So 83,800 minus 50,000. So we're going to have, or what I can do is, I may cut this, put it across over here, and let me put this PVCOF, or the initial investment, as 50,000. So therefore it's going to be easier for us to understand the remaining, right? So I'll take the values over here. So NPV therefore is equal to 83,800 minus 50,000, right? So you get the value as this. So if you look at the NPV, it is 33,800, 17,040 and 280. So we are going to same way take it for project B. Now what is that which is common over here? So maybe what we can do is stretch this across. The situation is going to remain the same, right? Okay, so this is going to remain the same. The columns are going to remain the same. I'll extend it here. So this column will be the same. Okay, so let me take it for B, or I'll just copy the whole labels over here, take it down. So that's easier for us. This is going to be same, right? The CIF is of course different. So let's take it here. The PV of annuity, PV at the rate of 15% from the annuity table is again same. So what is the PV CIF? This is equal to 30 multiplied with this. So 1,05,560, 67,040 and 80,448. The investment is the same. Okay. So the investment is the same. I'm going to take this. So this is equal to this minus this, right? So if you look at the answer, if you take optimistic situation, in case of A and B, it is 30,800 and 50,560. If you take this situation alone, project B is better. In the pessimistic situation, it is going to be 280 and 30,448. So most likely situation, it is 17,040. Now, if you ask me as to what will be the inference can however vary depending upon the risk-bearing ability of the decision maker. So considering, however, all the three situations for both the projects, it is observed that project B at any point of time will be better, because in all the situations it is going to give you profits, and hence it is recommended. Now, just in case if you feel that as a decision maker your risk-bearing ability is better, you may however take a decision. So as such, there is no hard and fast rule that here one should compulsorily recommend project B or compulsorily take up project A. So as I said, depending upon the risk-bearing ability, you can make the choice. So based on however the outcome, the values that I see, I am recommending something over here. That's given as my inference. So you may write, considering all the three situations, right, for both the projects, it is observed that the project B will be profitable in all ways. So therefore it is recommended. This is my observation, right? Hope you all guys understood. Thanks for watching my video. Try a couple of other questions. Thank you.